Okay, this is part 2 of our introduction to modelling a lamp, and you can see I'm just going back over the sphere, and we used a construction plane to split the sphere to therefore create the mushroom head kind of effect. I'm just saving the file now, and it's always a good idea to save as you go. Don't wait till disaster strikes. So I'm just saving the document into a location that the class can get to for future reference. Okay, so the intended manufacturing process for this product is going to be fusion disposition modeling, and so we're going to need to shell out the 3 components here to save material, and that will help with installation of the electrical wiring. So before we do that, what I'm doing here is just applying a gentle fillet here to the bottom edge of the shade. Anywhere where we think there are sharp edges, it's a good idea to add a fillet. And then the next operation is to just check the center of mass. So select the top level, all the components, just to see. You'll see there's a little glyph. It's a circle that's kind of split black and white. It's hard to see, but I can see there that the center of mass is good. And then the other thing we are looking at now is just to do a section analysis. And the section analysis is your best friend when it comes to understanding how different components sit or fit or mate together. And now I can see that cross-section view there, that section analysis. I decided to change the plane for the analysis because just to make it a bit easier. So I'm resetting that analysis to, and I'm using a different coordinate plane there. You can see it, the X, Y, Z. And now we can see how all those components are kind of overlapping each other. And so we want to use that to our advantage to help with adhesive. We're going to use an epoxy glue to bring the components together. It's a very strong adhesive, ideal for PLA. We want to create some surfaces for those components. So what I'm doing here is I'm just moving the neck and the head up slightly, and so we can see how that impacts the connection between the neck and the base. I think here I'm settling on 8mm, just a slight overlap there, capturing that position. And now I'm going to move the head around, so just select that component, and I'm using the arrows there rather than a free move because I want it to stay in place, but just constrain it to an axis. So I'm just moving it there. You can type in a specific amount to be more precise, and I want a little bit of overlap there. I've settled on 8mm as well for that overlap. Okay, so now I'm going to shell out the head component, and I'm using a shell thickness of 3mm. That's a pretty good thickness of the walls for 3D printing. It's kind of a good balance between strength and weight. And when I turn my section analysis on, you can see that it is now a hollow head. Where it was previously solid, it has been shelled out by 3mm to 3mm of wall thickness to create the hollow, and that's going to be ideal for the radiance of the lights. And you can see I've turned back on where I have combined the neck to the head, just to help us understand how that comes into that component. And now what we want to do is I've just committed another save, since that's a significant step here. Okay, and our next step here will be to, split the neck. Yeah, so we'll just take a look, turn off the other components and have a look at the neck. And again, that's a solid component, and with turning the origin on, I'm going to use the split body command first. I'm going to click the body to split. In this case, the splitting tool is going to be the vertical plane from the origin, because I drew that shape on the origin. That is the perfect center. And now if we expand the component, you'll see there are two bodies, and good to name your bodies as you go. So I'm naming this one here left, and the other one will be, of course, right. Now as we go back through the browser, we're able to quickly identify parts. So I'll turn the left side off, and you can see we have a solid right, and that will be the same for the left. There'll be two solid bodies. So essentially what we want to do is we want to shell out this solid body, these two solid bodies, together as well, saving filament, and use the same wall thickness as we did for the head component. And so once again, we'll use the shell command, and I would just like to see that on a isometric view. Oh, sorry. So what we're going to do now is insert a derived component. I have already modeled up the switch. This particular product is going to utilize the circular switch. And when I'm bringing this model in, you can see actually two configurations of the model are appearing with different tolerances. And so I'm selecting the one that has a more generous tolerance, a loose tolerance, 0.6, which essentially means it would be a bit easier. The idea is it's a bit easier to fit into the model. So now you can see I'm going to have to reposition the switch. It's been brought in because I have component color cycling on. It's been brought in with its own unique color. I'm breaking the link here, so you can right click a derived component, break the link, and that lets it become its own body in its own right, which lets you make different changes to it. If I didn't break the link, it means that if I made changes to that switch component, they'd be automatically, dynamically reflected in any project that it is used in. In this case, I decided to break the link just to give me a bit more flexibility. So again, we're using our view cube, and to help us navigate around, I want to make sure I'm looking very specifically at certain views of the model. So here we see the split line, and I want the switch, these two halves to come together eventually with the switch in between. So I'm just going to very sensitively manipulate the switch into position. The prototype shows me the approximate location for the switch. So again, I'm using my views carefully, zoom in and out, and I'm going to change the angle here with the manipulator, zoom in a bit so you can see what's happening, and angle the switch onto an appropriate angle. And essentially what we're going to do is we're going to create the correct size hole for the switch by combining this switch component with and using a cut combine to cut a hole out in these components, the neck components, for the switch to be installed. So again, just go back over, check your views. The angle has been checked on a different view. I'll capture that position and click OK. Now when we go home, you'll see the switches in its designated location, and what remains is for a hole to be created in the neck. See, I've just turned off the switch. You can see there's no hole yet for it to be installed. So we can just ensure we're going to turn off one of those halves of the neck. I'm using the shell command first to shell it out to 3mm, just like the other components, and then I should do the same for the other side. If we turn around, you'll see that's also a solid, and that's going to be shelled out, touching that side to 3. And now that they're shelled, we'll turn them back on both together, turn on the switch, and notice the shelling is done first before we combine. So now we're going to combine this switch will be the tool body, so make sure you select your bodies carefully. So I go back in because I did it incorrectly. The target body is going to be the neck, and the tool used to do the cutting is the switch. So I make sure new components off, but keep that tool as on. When we click OK, we can turn off the left and see the result by turning the switch off too. There's the hole created for the switch. That will be repeated for the left side. Combine, use the switch as the tool for cutting, keep the tool, click OK. So we have a shelled out head that will radiate the light. We have a shelled out neck that also will allow for the switch to be installed. And we're just turning those components back on. And what we still require is the base. We need to have the neck sitting into the base nicely, and we're going to need a channel for the cable that travels up the base, through the base, up the center, through the neck and into the head. That will be happening very shortly. So here you see I've turned the base back on, and I'm going to use the combine command once again. This time I'm going to be paying attention to what's the tool target and splitting body, or tool body. So I want to use the neck as a tool to combine cut into the base. So I'm repeating that again. I've done it the wrong order, so again, choose that target body, choose that as the tool, keep the tool, click OK. Turn off the neck to take a look. Something's happened, I haven't done that correctly, so what I can do is just go back in time on the timeline and right click and edit the last operation, and then use that to cut the correct tool. So I'm just going back over here and making sure that the combined cut operation is correct, and I can check that by turning the neck component on and off, and there you see it has cut into the base, which is what I want. I want a slight surface area for the epoxy adhesive to help glue these parts together. So now I'm creating an offset plane, and I want to create that offset plane from the base, the bottom of the base I should say. Almost. Have to split it into two parts. Too long. Okay, so now we're going to split this base. We want to split the base because we need to install the power cable. And what I'm doing here is using the inspection tools to check the thickness of the base, and it was 15. So what I want to do is basically use half of 15 to create a construction plane, which is what you see I'm doing here. I just created a 7.5 millimeter construction plane, and I will use that plane as a splitting tool to split this base perfectly in half. So now I'm just trying to find the construction plane, and I turned off the base here, and if I go under construction plane, there it is. It goes red, that's the splitting tool. Just check the front view, it's halfway. Click OK. If I turn that base component back on, and I can just verify that it has been split in half. So I'm going to shell out each half, and we can confirm that by looking at the bodies that have been created and naming them appropriately so that we don't get confused. What I actually end up doing here is giving them the wrong names. I just have to swap them around, so I do that there. That's all I'm doing. I'm just renaming my mistake. And I thought I'd leave it in the video here just to show you that mistakes are important, and you just got to use them as opportunities for learning. So now I want to shell out this 3mm wall I have. You can see that's the bottom of the base, the bottom half. I've turned the top half back on, and I'm going to turn it upside down and click that face to shell it out to 3 from the bottom as well. So now we have shelled out the base, and we have 2 parts to that base. It's split in half. What remains is to create a channel for the electrical cable that's going to run up the base center all the way through the neck up to the head of the component. And so what I'm trying to do here is create a sketch so that I can do that. So I'm drawing a circle just at the bottom of this, the bottom body of this base. So just had a quick measure of the cables, and 8mm should be enough, more than enough space to run the cabling. I've selected the sketch so that I can use it to do a cut extrude, and you see I'm just turning on bodies now, and if I change my view and change where I start from by clicking the underside of this part, that's where I've decided to start the operation from. That's what you saw me do there. Now I can go back and turn on the other components and zoom out a little bit and extend the extrusion all the way up the center. If I change my view, again I want to also cut through into the head component, so I'll turn that one on and just look at it from the front view, and you can see the hole is extending up. Turn my section analysis back on and change my view there, come in a little closer, and you can see, yep, I definitely have a channel for my wiring going all the way from the base, an 8mm cylinder being cut through 3 components, and that will allow the LED to be shining brightly in the head of this component. What remains is for the power cord, and to deal with that, what I've decided to do is create a square or a rectangle on the opposite side of the switch. So here you see I've turned around to the opposite side of this model where the switch is. I'm creating a new sketch, turning off what I don't need to see, a new sketch on the YZ plane, and turning my base back on. I'll create a rectangle here, so I can't see it, so I turn that base on. This is where the USB power cable, and I'm creating it between the splits. So you can see the split line there between the bodies, and using a 4x4 square I've created the sketch, and then in a similar fashion to where you saw I use the circle to create an electrical channel, I'm going to use this sketch to cut a hole in the base, and this will be for the USB power supply. So what I'm doing here is it's at the moment right in the center, but I want to cut the hole out to the side, and I know the diameter of this body is 110. So you see I'm going to offset this. I try to use a formula, but it doesn't quite work, so that's alright. I decide to just do the manual math and use a 55mm offset. So you can see I've come back on my calculation there and just put in 55. And now when I start to extrude this shape, it starts the extrusion at -55 offset, not exactly, you see where it's happening on the screen, not exactly where I drew the sketch, but out at 55, -55 in this case, millimeters away. So that you can see, to confirm that it's cutting through, I'm going to turn off the top of the base. There we see it's coming through. And here's a little trick too. I'm coming in close, and for the extent type, I'm changing it from distance to object. So I'm going to click the inside wall. In this way, if I change the wall thickness, that hole will also adjust automatically. So if it changes it from 3mm of thickness to 5, the hole will adjust automatically. And there we have it. I have created the outlet for and inlet for the USB power supply. It's going to come in and up through the center circle, all the way up through the neck. It's been shelled out, connect to the switch on the side, and then connect to the LED light, which will be housed inside the head of this product. And that is part 2 of this tutorial on how to model the LED lamp.